All right, hello. Today I'm going to be presenting some research, Elegance and Effectiveness, a guide to clean code. So who am I? My name is Ashley. I am a second-year security major. I am the current president of WeSys at RIT. I am also the Ops Cloud team lead. I do a lot of offensive stuff. I'm the Offensive Academy mentorship group leader. Love Linux and Vim, clearly. I also played table tennis. That's 6 to 8 p.m. on Saturdays. Y'all should go. And I also worked at an FFRDC over the summer. Ooh. So what's the motivation of this presentation? Well, I love writing software. I love writing malware for Red Team. I write automation tools for my home lab. And I've also run a lot of stuff for my co-op. And I wanted to build something better. I found that over time, the code became hard to work with. It didn't deploy correctly. And I lost a ton of hours doing development when I could have been just doing more work faster and better. So what is bad code? Well, I have this little infographic up here, and I think it quite describes the process well. And basically, it's what the fucks per minute. Good code, when you're doing code review, you'll get like 1 or 2 what the fuck. Like, what the fuck is this shit? What is that line? You know, stuff like that. But if you're looking at bad code, you're like, oh no, what's going on here? What have we written? You know, it's just terrible, and it's very, very abundantly clear just at a glance, like, hey, this shit sucks. So yeah, it's hard to understand, it's hard to work on, it's hard to read, and it's hard to scale. When you're trying to work on bad code, it's impossible. It's just really hard. You're gonna have to wade through, you know, just cesspools of bad stuff. And so what should have taken 1 hour often takes you 10. When I'm doing development, if I'm working with a clean code base, I can be in and out 30 minutes. If I'm working with something bad, it's gonna be 4 or 5 hours. I'm looking at a Red Team repository. Oop. So what causes bad code? Tight deadlines. So oftentimes we're forced to push ourselves. We're stressed out. We have this assignment done. We gotta finish it by the end of the day. You know, we're working in 123, 124. We're working on a project. We're trying to deploy for a competition. We push ourselves. You know, we work past it. We just have that get-it-work mentality, right? This is actually a poor line of thinking. Basically, when you are doing that, you're actually creating messes for yourself immediately, and you're going to have to work through that at each individual step. And so it's actually a lot easier to start with a good, clean code base. And the other thing that can cause bad code is you don't know really what it looks like. One of the things you can find is when you talk to security-focused people or developers, they can often tell you exactly what they don't like, but not exactly what they do like. So I'm going to teach you guys that. So there's a better way. Clean code is much easier to work with. You'll find that when you are putting a lot of care and effort into your code base, when you're putting a lot of effort into your assignments, it's going to be a lot easier to write. And it's going to be a better experience for you. I think it's much, much easier, and I know I personally enjoy working with some nice, good, clean code and not that garbage that I see every day. So what is clean code? Well, this is a really great quote from Michael C. Feathers that I'm going to read from you guys. He is a software guru. If you want to know anything about good design patterns, good ways to build your stuff, he's the guy. Clean code always looks like it was written by someone who cares. There's nothing obvious that you can do to make it better. All of the things that you thought about the code's author, if you try to imagine improvements, you're led back to where you are, sitting in appreciation. Code left by someone who cares deeply about the craft. So TLDR, the author clearly cared. They put a lot of effort into it. You can tell, you can just read through it. You can see, oh, this variable is named that Y for this reason. And everything is just abundantly clear. You can read it like a book, top from bottom. It'll make perfect sense. And you leave it without having to go back up, reading all these different methods, reading all these functions, trying to decipher what's going on. You read through it once, you have a good idea of what's going on. And there's nothing obvious you can improve. If you try and make changes, oftentimes you will find that you're actually just making worse versions of the code itself. I've done this before. I've looked at a really, really good repository, and I'm like, oh, what if I just change this thing here? I realized, oh, that actually doesn't make any sense. And there's this idea in there of software craftsmanship, really taking ownership and pride and joy in the stuff you're doing. Because we're developers, we're CSEC professionals, we're going to be writing a lot of code, whether it's scripting, whether it's assignments for your classes. Let's take some pride in that. So the first thing, meaningful names. What do you normally name your variables? When you're doing an assignment, you're doing it quickly, you do your for loops, you set, your variable I, stuff like that. Probably looks something like this, int d. And we write a little comment there to remind ourselves what this actually did. So when we look at it 10 days later, it'll make sense. It says elapsed time in days. That's bad. Without the comment, I have no idea what this does. We removed that little line, int d. What does that mean? Can anyone tell me what int d means? I have no idea. Don't do that. What if we did something like this? Elapsed time in days, day since creation, day since modification. These are all very clear of what I'm looking at. You don't need a comment. You don't need any little extra cruft in the lines. It's just unnecessary. Name your variables clearly and with intent. Lying is also bad. So what about something like this? Do we see any problems? Well, our variable name is a count list, but we're saying it as a hash table. I see this all the time. We just like to tell little lies in our code. So yeah, it isn't actually a list. And say I was a developer working on this. I haven't looked at the code before. I see this variable name. I'm going to try list-specific methods. I'm going to try to append to it. I'm going to try to remove at a certain index. And I'm going to get a bunch of errors. You want to know why? Because I didn't think clearly enough when I was initializing it to give it a good name with what it actually is. So don't lie in your code. Purposeful distinctions. So we have these three methods here. I won't say which code base this is from, but it definitely is out there. We have get active account, we have get active accounts, we have get active account info. Currently, we are working against ourselves right now. We have this fancy little thing called Control F in our nice little IDEs in our web browsers and stuff like that, where you can search for specific method calls. If I type in get active, it's going to pull up all three of these. If I'm a developer and I'm working on this, it's not obvious at a glance what I need to actually be calling to get exactly what I need. So make your methods, make your functions very clear. So the real awful stuff. I've seen this before. I've seen it in my code as well. I literally have no idea what these do. I named them because I was trying to be cute. I was trying to be quirky. Don't do that. Don't be cute. Give yourself meaningful names. Yeah. Oh, yeah. Oh, yeah. You see that they don't care. It's obvious. There's also this thing called bloated functions. So if we're looking at this, I can straight up just not tell you what it's doing at a glance. I have to kind of spend like a couple seconds looking at it. It's parsing some JSON. It's adding to a database. It's building a query. And then it's returning that output. That's way too much at the same time, man. Doing too many things at once. So what is a good function? Well, a good function does one thing well. A function, you think of it, it's one unit, should be doing one thing. And it should be all at the same layer of abstraction. So say, that function, it was add command, it should be doing, all the things at that layer, that high level layer that's doing all that, and it should call the other functions that are doing smaller things at the lower levels. And bad functions try to perform multiple things at varying layers of abstraction. So doing that high level thing, adding a command, and that's handling all the nitty-gritty at the same time. That's bad. So how would we rewrite the function from earlier to fit into our new paradigm, or our new clean code philosophy? Well, it would do one thing. And so you see here, we're basically taking that big high-level thing, we're putting it down into a whole bunch of small problems. We're basically parsing our JSON, we're committing the command to the database, we're getting the result, and then we're building the output. And you can see clearly, it is very obvious what this is doing. It's adding a command. Well, that's what the function name is, but earlier the code wasn't reflecting that. So making sure you have that ground truth in there. You'll also notice I don't have any comments in here. That is because it's abundantly clear from the function names, from the variable names, exactly what it's doing. And so basically, one unit of thing. You want your function to be doing exactly one thing at a time. Oop. So what constitutes a good comment? I was talking about that earlier. There's no comments in the code. Sorry, my laptop's a little slippery. Well, there's this really great quote. Robert C. Martin, he's also a software guru. Basically, all the stuff in this is from a little book I read called Clean Code, Handbook in Agile Software Craftsmanship. And basically, he talks about how comments in your code are failures. They are a failure on the part of the programmer to express themselves in the code that they're writing. And basically, every single time you write a comment, you should be thinking about, okay, what did I do to get here? How did I fail as a developer? How did I fail to express myself properly? If you're doing it well, you really shouldn't have to that often unless you're doing like super complex, like a fancy little algorithm, and even that should just have like one line to explain itself. And so why are they bad? They lie. They lie a lot of the time. How many times have you read through bad, poorly outdated documentation, and you look at those actual function calls, you look at those endpoints, and they're just not even close to what it's doing in the code? That happens all too often. Developers are lazy. People are lazy. They're not updating their documentation. They're not updating their comments. Why not just have the ground truth in the code? They're also away from it. So it's this layer of abstraction above it. You're separating yourself from the ground truth. That's really bad. And they're also a crutch for bad code. So oftentimes, you're writing your software, you're going through, and you're like, oh, this is a big pile of crap. Let me just comment all of it, and then it'll be perfect. No, that's terrible. Just write good code. It also bloats good code. So say, I'll have an example in a bit here of something that's perfectly reasonable that's just riddled with comments that are super unnecessary. Don't do that. Don't add unnecessary stuff to your database. So here's some bad code. Credits to the GCIS faculty. Thank you very much for providing this. They didn't actually provide it. I just ripped it. So what are some issues here? Well, if you took away the comments, it would read just the same. For those of you that haven't taken this class, this might not make a little sense, but if you've written any Python ever, this will make 100% clear sense. Basically, it's just returning string representations. We have our function calls repr and stir, and then it writes a little comment describing those built-in function calls for us. This is useless. Don't do that. So what are some good comments? Well, I've talked a lot about how comments are bad, but I actually document all of my code. If you watch my previous presentation on Bifrost, you'll see that I actually have all the docs hosted on a separate web page. Well, like I was saying earlier, sometimes it's hard to express yourself just in your code. And so I actually always document basically everything I do. And also, the other motivation is I want my project to be clear for new users. So in that previous example, if you were reading it as a Python developer, you would see those 2 lines of comments, and you would completely ignore those. They're useless. It's just extra stuff. It's gratuitous. But if you're a newer developer, those are going to be pretty useful for you. And so I try and make most of my software friendly for all different levels of users and levels of people that are reading it. And so that's when you should comment. That's when you should put in that extra stuff. And so I'd be remiss if I didn't talk about OOP, or object-oriented programming. This is a programming paradigm. It's basically the idea that you're having these things called objects. Most of the time you'll find this is in classes. So if you have taken C++ or Python or Java, you'll know that they have a built-in data type called the class. And they're very useful for organizing your code, especially when you're passing around lots of different state. What I mean by that is, say we're writing like a port scanner, say we're writing like a web request finder, and we have a lot of different things we're passing around all at the same time. Say we have, like a global variable called our URL that we're, passing around a whole bunch. It's so much easier just to encapsulate that within a class and not have a global. Say we want to change it sometimes. It's just much easier. And it's a lot better way of thinking about your programming. And there's these things called solid principles. What are those? So the first one is the principle of single responsibility. There should never be more than one reason for a class to change. Basically, all this says is that classes should do one thing and one thing only. So it's that kind of idea between a multi-tool and something that's really great at its job, like sauce, scissors, knife, all that kind of stuff. Basically, it goes back to clean code principles. You want your functions to be doing only one thing. You want your classes to be only doing one thing. So say I had a class called like web scraper or a class called port scanner. They wouldn't be doing interchangeable jobs. It would just be doing that one thing, and I'd have separate classes for all that kind of stuff. That's all this is talking about. Open-close principle. So the idea basically that all of your classes, all of your software should be open for extension, but you shouldn't have to modify the base code to be able to extend it. Basically what this means is you want to make your programs modular. You want this basically idea that you can go in and you can just build upon everything else without having to change the original software. So you have good abstractions, you have a nice SDK for developers, And it's really, really nice. And it's a good development experience, too, because you don't have to modify source code that's going to make breaking changes, and you don't know what they are. It can be really bad. It can be ugly. So the Liskov Substitution principle. There's this nice little meme that perfectly describes it. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. So there's this idea in OOP, basically, that you have your main class, and then you have subclasses underneath it. You should be able to interchange those without breaking the code. You should be able to put a subclass inside your main class. And in this case, if you have a duck and you have a remote control battery duck, you can't swap those in the code and make it still work. This thing needs batteries. It needs to be able to run on that. And it's not going to be a good time. And so basically, it's just the idea that, hey, if you need a robot battery duck, you should probably have another class. It's not a duck anymore. Let's be real. Interface segregation. So this is the idea. You see this little beautiful dependency graph. I'm sure that's some of your code out there. I've seen it before. I've written it. You do a pip freeze. You look at your requirements, and oh my lord, it's just 200 lines. All these different dependencies. They require multiple things. You have circular imports. It gets really, really gross. And so basically, it's the idea that if you have this high level or low level of abstraction, it shouldn't need to depend on other parts of your code. So say I'm making a web scraper. It shouldn't, my high level functions and my low level implementations shouldn't have the same amount of requirements because they're doing different things. And so basically it's this idea that you're separating your dependencies and you're making it a lot easier to work with without screwing things over and having to do a whole bunch of imports and add a whole bunch of bloat to your code. Dependency inversion. So basically, this is saying depend upon abstractions, not concretions. Concretions are things that you set in the code. And so a very easy way to tell that you are failing this principle is if you have to change a single value every single time because it's hard-coded in somewhere. Basically, it's this idea that you should have, basically your abstractions rely upon non-concrete things, so non-single statements. So say, back to that example earlier, we were talking about that header URL in our web scraper. That shouldn't be hard-coded in at the low level of abstraction. It should be pulling it from somewhere else. That's basically the entire idea. Yeah. And so style guides. So there is this great quote from Guido. We have a whole lot of quotes here. I'm a big fan. I like learning from good developers because that's the best way to learn what you're doing. Oh, we love Guido. But basically, a foolish consistency is the hobgoblin of little minds. Ouch, that's a little harsh. But basically, consistency is key. It is also important to know when to break from it. So if you're writing code and you're following a style guide and you're like, hey, this doesn't really make sense. Why should I have it like this? It really would look better in this specific case if it was like that. Go for it. Do it. Don't be consistent just for consistency's sake. Oftentimes, it'll make your code look worse. It'll make your documentation look worse, especially, everyone's is different. Make it tailored to yours. Speaking of style guides, some examples. So a lot of you guys are in 123 right now. You're taking Python. I'm sure you've heard of Pep8 or Guido, hopefully. Hopefully they teach that in those classes. But basically, it's a really nice style guide. There's a whole bunch of different tools, too, that you can use to auto-format your code just so it's compliant. They're super easy. It's literally typing the command and then dot, so it recursively goes through all your different stuff. If you're a Rust programmer, you probably already know this, but there's the format or RFCS or whatever. I know Alex doesn't use it. And then for Java, there's the Google style guide, and then there's the Oracle style guide. Basically, it's just a way in which you can make sure that your code is consistent with other code that's being written in that language. And so if you have other developers that are looking at your stuff, they're not going to go into that room in the code review and be like, what the fuck, what the fuck, what the fuck. It'll be like, what the fuck. This is not terrible. And so some useful tools. There's this really cool one that I discovered recently. I'll have another talk about this, all just on Git stuff, but there's this thing called pre-commit. Basically, you've learned Git. You do your Git add, you do your Git commit, and then you do your Git push. This comes in at the Git commit phase, and basically it runs a whole bunch of different checks. So it makes sure that your code is compliant. It makes sure that you don't have trailing white space and stuff like that. That your syntax is correct on everything. And it'll actually reject your commit and then fix your files for you if you're out of line. I love using it. It helps make everything just very nice. There's also modern IDEs, so stuff like PyCharm, IntelliJ, NeoVim, if you're like me and love that kind of stuff, clearly. And there's also VS Code, which is pretty common. And they have some very nice extensions for that to help you write some good stuff that doesn't look like complete garbage. Ooh. So some code smells. So what's a code smell? I was talking about that earlier. IDEs help prevent bad code smell. There's basically 5 main things. So there's bloaters, which I was talking about earlier. This is basically stuff where you have overloaded functions, you have overloaded classes, you have comments that are way too big to fail. They're like the banks of America. You don't want them. They're really bad. They're just going to make everything crash at some point, and you're going to have to pay the cost for that. You're going to have to do so many hours of refactoring. It's just not a good time. Object orientation abusers. So we talked about the solid principles earlier. It's when those things go too far and you're misusing those principles or you're doing them badly. It's when you have a billion different dependencies in your low-level abstraction. It's when you have hard code requirements. It's when you basically mess up all of that. Change preventers. So one of the keys that you have messed up when you are doing development is when you make a change somewhere and then you have to make 10 other changes in other places. That is a very surefire sign that you have done something wrong. And basically, you shouldn't have to basically change all that stuff all the time. Say you have a hard code requirement, put it in a .m file, pull it from there. You shouldn't have to be hard coding it over and over and over again in your code. Dispensables. So these are things like the comments I was talking about earlier from the GCIS faculty. Thank you so much. Where basically you can remove them and the code value stays exactly the same. I'm sure many of you have written code where you could actually just take out a function and it would perform just the same, and then you wouldn't have to read that garbage. And then coupling is the idea basically that you've wrapped together too many different classes, you've wrapped together too many different dependencies, and they're all relying on each other for no clear reason. This can happen often in Flask apps where you're having circular imports of different things. There's better design patterns for that, and you can fix it. So in conclusion, clean code occurs when we take ownership of our software. Remember, it is abundantly clear when someone cares versus when they're just trying to hit a deadline. So try and think about that next time you're writing your code, next time you're writing software, next time you're rushing yourself because the assignment's due at 11:59 and you just started at 11 p.m. Think about these things. So here's my contact info, LinkedIn, GitHub. I write a blog where I do home lab stuff and a whole bunch of fun things, and then I have my Twitter as well, and then sources. So thank you. Are there any questions? I see Anthony over there. I'd say 100% of the time. I always think about it. 2 months ago.